Part B is the same scenario, except that now it's asking us, okay, as the ball passes over the tree, what is this displacement? Or, let me turn this back on for a second here. I wish I hadn't done that. Yeah, why not? I'll just erase some of these, get all this junk out of the way. This is my scratch layer, so all the other scratchings are still on it. For part B, we want to know what is this displacement right here as the ball passes over the tree. So we want to do two things in order to solve for part B. Part B, number one, we want to use the initial velocity, which we found actually in the previous problem, to find the horizontal time to the tree. Okay, so the initial velocity, I should say, I'm sorry, in the x direction. Initial velocity in the x direction to find the horizontal time to the tree. All right, we know the distance to the tree, and we know the x component of velocity. We should very easily be able to solve for the time. Secondly, we want to calculate what the initial velocity is in the y direction, v(i), y, and use that in conjunction with the time to the tree, that is, how long it's been in the air vertically when it reaches the tree, to determine the y displacement at the tree. That'll tell us right here where the ball is in the air above the tree, and that'll give us how high it is above it. Okay? So let's do that. So, what's our initial velocity in the x direction? Well, we calculated it before. Let's just do it again real quick. That is the total displacement in the x direction. That's 17.8 meters divided by the time it takes to get there, 2.24 seconds. And that gives us a horizontal velocity, you might say an x component of the velocity, of 7.9 meters per second. Okay? What's the time to the tree? Time to the tree, T-R-E-E. I'm going to write it kind of like that. Well, if velocity is displacement over time, then that means that time is displacement, in this case in the x direction, over the velocity that it takes to get to that displacement. Initial velocity in the x direction. So we're solving for the time to get to the tree horizontally, which incidentally is the same time to get to it vertically, but I'm getting ahead of myself here. So what is this? Our displacement to the tree is 14.0 meters. The initial velocity getting there, and well, the velocity at any one point getting there, because there's no acceleration in the x direction, is 7.9 meters per second. So if we calculate that out, that tells us that the time to the tree is 1.8 seconds, right? 1.8 seconds. All right. Well, we have the time to the tree. We got that. All right, so that's part one. Part two is we want to calculate initial velocity in the y direction. Okay, well, the initial velocity, we got that from before. Our initial velocity we calculated in part A. That's this right here, part A, 13.4 meters per second. So let's write that down in part B. Initial velocity, here we go. Initial velocity is 13.4 meters per second. So the y component of the initial velocity, in the y direction, that is the full magnitude, that is initial velocity, times the sine of theta. Or you might say it's 13.4 meters per second, I'll just write that in, times the sine of 54. So this tells us that the y component of that original initial velocity is 10.8 meters per second. All right, that is, turn this back on. Uh-oh, I'm losing it here. 10.8 meters per second. That's this right here. 10.8 meters per second. I don't know why I'm just not marking up on this layer here. Yeah, I'll do that. Okay. VIY is 10.8 meters per second. So that should give us an initial velocity of the ball moving upwards. And with that, and with what else we know about the y direction, we should be able to calculate where it will be when it's at the tree right there. Here's how. Okay, I'm going to write this for y displacement above tree. I'm going to list everything we know about y. Initial velocity in the y direction, we just found that, right? That's 10.8 meters per second. The time to the tree, T-R-E-E, sorry. Time to tree is 1.8 seconds, right? Because it's the same horizontal as it is vertical. What's the acceleration in the y direction? We all know that. It's negative 9.81 meters per second squared. And what we want to find is the displacement in the y direction at the tree. All right, so what is that? Do we have any equations for displacement in the y direction? Yeah, sure we do. That's, well, we have displacement is initial velocity, in this case in the y direction, times time, plus 1/2 times acceleration in the y direction, oops, times time squared. We have all these other values up here, so it should be very easy to solve for our displacement above the tree, or at the tree. Delta y, the tree, equals what? Initial velocity in the y direction, that's 10.8. Times time, that's 1.8. Plus 1/2 times acceleration, which is negative 9.81, times our time squared. 1 times square. I just thought of that. That's funny. Times our time squared. 1.8 squared. All right. So key that into your calculator, and that means that our I'll just write it over here. Our displacement above the tree is going to be, or displacement at the tree, you might say, is 3.55 meters. That's where the ball is above the tree. Now the question actually asks how high above the tree is it, so technically let's answer the question. It clears a tree which is 3 meters. Subtract that from 3.55 meters. Clears the tree by 0.55 meters. And that's it. There you have it. That's example 4-5 in our notes. And that wasn't too bad, was it? So if you have any questions, please come see me tomorrow. Tomorrow's going to be a work day. And we can go over this or any of the problems that you need to do for homework for the following day. So I hope that helps, and I'll see you tomorrow. Take care.